Hey everyone, welcome back to Ground Zero. It is episode 12. Today we have Francesco from Paradigma. Francesco goes with the name TensorQT on Twitter. They are building infrastructure for autonomous research. The core product is called Flywheel, which replaces papers and notebooks with DAGs, basically directed acyclic graphs, where every experiment is a node with tracked lineage. The idea is that AI gets better at running experiments. The bottleneck shifts to organizing what it produces. Francisco has a physics background, did PhD research on transformer dynamics at Sapienza, and started Paradigma to build what he sees as the missing layer underneath all the auto research work happening right now. Francisco, welcome.
Thank you so much for having me. It's great seeing you in real life. We've only interacted via Twitter before, so thank you.
Awesome. Likewise, actually. So let's start with the team and about the idea itself and about you, actually. So your path to this is kind of bit non-obvious. You started in physics at Bologna, went to mathematical engineering at Politecnico di Torino, got into Alta Scuola, spent the time at Kyoto Institute of Technology, did research at INRIA, a fellowship at college, the engineers, and now you're doing a PhD at Sapienza working on how transformers compute internally. I mean, what I generally see, it's like you're pretty much packed with a lot of research and experiment background. So what's the thread connecting all of that? I'm just curious about knowing more about your background and how has it been like?
Yeah, it definitely feels quite sparse as a trajectory. I mean, as a graph, even it will look pretty weird. But there definitely is some underlying thread underneath the entire thing. So, like as you said, I started out with physics, but I think one of my my first kind of viral tweet was actually about this. It was about kind of machine learning really being this our time's great challenge, which is in the first place the thing that brought me to physics. When I started studying physics, I had in mind the possibility of discovering the universe and beating this enormous challenge of knowing, what's the underlying laws that govern the universe, and it just happened that in the meantime that I was studying it, it became very clear to me that the next challenge would be different. It will still contain science, and many of the things we're working on as physics students as well. So actually, I did my bachelor's thesis already was in geometric deep learning, which is how I actually got into deep learning and neural networks in the first place, which is weird. Usually people go like through different routes, and GDL was already like pretty involved as a subject, but I really liked it because I liked differential geometry, and I liked the mathematics that I was studying in physics, and that helped me kind of gracefully move into the field. And yes, I mean at that point it was very clear to me that I liked the mathematical part of machine learning and the dynamics of learning, and I was really curious, and still am today, about how it really works. So I moved to an applied mathematics, which is called mathematical engineering, in the university I attended, and then for my master's thesis, I worked on applying that to spectroscopy, to molecular structure prediction, and basically that led me to continue this line of work in my PhD. Which I dropped out of my PhD, so just to clear the record here, I'm not a PhD student anymore, but I was just a couple months ago. So
how was the experience? Do you like how the academic has academic TensorQT? How is it what like for like 2 years ago versus now? What the change feel like? Like right now you're building the company. Any connecting dots there? You still find there's a lot to do with what we do with rigorous curriculum in academia and what we are actually doing in industry as per the experience.
Yeah. I think unfortunately there is a giant gap, and a lot of the motivation for moving from academia from a lot of people, not me specifically really, but for example for Emanuele, one of my co-founders, our chief scientist, is that the real frontier stuff can only be done with the kind of regularization of having it be applicable in industry, and of course the money that comes with it. And that's, I mean, academia is, I think, in the future going to transform dramatically as an institution. It cannot stay the way it is. And the jump was big in the sense that the rhythm of your daily life is very different. Fortunately enough, it wasn't my real first entrepreneurial thing. I which is also kind of part of my jagged trajectory. But I co-founded, when I was in my bachelor's, I co-founded a nonprofit, and so there was also this.
Sparks, if I remember.
No, that was actually a consultancy that I did for a while. But the nonprofit was EXO, and it's cool. You can find it on my LinkedIn, I think. But the cool thing, it was about mitigating brain drain from Italy, and so I'm still in the fighting for it, I guess, even though I'm not running it anymore. But yeah, big change, definitely big change in academia, and I think one of the things that makes kind of industry very attractive is the speed. I think academia has
Yeah, go ahead.
I was saying, like, I think academia kind of inherits the, let's say, mechanisms of universities and institutions and kind of the bureaucracy that go with it. That's great for like a very well established field like physics or mechanics or whatever, or chemistry, but it's not for machine learning.
You just mentioned about you were building something for prohibiting brain drain from Italy, right? So I'm curious. So you're building an AI infra, a frontier company from Rome now, and I mean your backers are like Emergence, Partech, and other venture funds. So that's pretty kind of, I think, unusual investor mix for a deep tech AI startup about the combination. Anyways, so what does it feel like building this from Italy? Does the location actually matter when the product is software, and how the gap is, let's say, when you compare to West, let's say in SF or Bay Area? So how does it feel like?
Yep. I mean, first of all, if you're trying to do a generational company, if you're trying to build something at the frontier, you should be doing something that's different from everybody else. I mean, at least, I think there's at least a justification in this. But jokes aside, the, let's say, choice of staying in Italy, apart from being patriotic and apart from being, making it a from first principles decision, which it partly is, is also very strategic for us. I mean, how does it feel? It feels, of course, I think the first thing you're going to hear when you're raising money is you should fly to SF as we speak. And people will really push you. Like, I mean, everybody has a very locked in mindset on SF being a very strong cluster, and kind of the culture being in the air. And by any means, I mean, I will be there as well in San Francisco. I'll definitely come in the next few weeks and chat with some people. But, I think that over time, a lot of that kind of cultural proximity is filled by actual proximity in the cyberspace, in the sense like X itself, I think, is a beautiful example of this. None of the company that I'm building, none of my friends would be what they are if I didn't have my X account.
Even this,
I wouldn't be here at all. Like, I met Giulio on Twitter. Emanuele came. I met him due to an event that I did thanks to people from Twitter. A lot of people that invested in the company, we contacted them via Twitter, and people that I might have, like Thomas Wolf, for example, is an investor in our company, and he answered me, he replied to me in an XDM, and so it's really really cool. And then there's a second reason, which is I think there's a very unfair advantage in the talent that you can poach from in talent pools that are kind of dispersed, that are kind of all over the world, in the sense that some of the best researchers in the world today are very young, super plastic, especially machine learning. Like, you need to be very plastic. Like, it doesn't really matter the experience. And I mean, an example is Callum Ace. Like you've had him on the podcast, or Grad from Premelect, right? And there's a bunch of those, and those people, when they're so young and they're so good at it, they're somewhat self-propelled, and you can find them anywhere. And a lot of them are in Italy, and we have a privileged access to them that nobody else has. And so that's a very strong strategic advantage that we're gonna have.
I really feel the kind of age we are living in, the kind of technology we are kind of building up, it is pretty much new to everyone. And the major alpha to people who are building, who are very young, like you have given example of Calome's Grad. So the kind of curiosity, the kind of nodes they can explore, if I talk about in Flywheel term, so that's pretty pretty interesting. And as people go old, it feels like they're pretty much constructed, they're pretty much restricted with a lot of other things as well. So I think it's pretty much generational opportunity for anyone young building out in this space. And on the same note, I had one other question for you. So the European AI ecosystem has, I have really seen that they have strong research universities, but really few frontier labs compared to, let's say, US and China. So does that shape you how think about the product or who your users are?
I think it. So first of all, we're not a localized company when it comes to who uses the product. Like most of the people using the product are from the US, and I mean that's what we expected in the sense that the, let's say, level of early adoption is of course concentrated, in those places in which AI is at the forefront of everyone.
But I'm curious about adoption in Europe or Italy here.
Yep. In general, I think yes. Let's say in Italy and in Europe, we're definitely talking mainly to research institutions that are really interested in using this, because I think that I think we're going to get into this when we talk about Flywheel, but everybody's already using Flywheel in their head when they're doing research.
Yeah.
It doesn't matter. It doesn't matter if there's a web UI rendering it for you, right? Everyone is always thinking of trajectories and places they're going. And one of the things people tell us about is that basically that trajectory being confined to a person's mind makes it very hard to transfer to others and to collaborate and to maybe pick up from someone's work. So that I think that in Europe, what we're seeing is a lot of, let's say, research institutions are liking it. And I mean, despite this, I think we want to push for existing frontier labs in Europe to adopt this kind of thing. So
I mean, yeah, makes sense. Great. Also, I've got this question. You have been building Flywheel. You started bootstrap company. So how far did you get before raising the funds? And what really made investors to say yes? Because there has been going a lot people doing with Autoresearch stuff. Basically, the fundamental principle of what Flywheel actually is, what Paradigma actually is.
Yep. So actually, we've been working. I think we started working on this at the beginning of November of 2025. We of course had. So the way that we started working on it was a mix of my habit as a researcher, which was kind of still producing these kind of trajectory-like experiments and being really bottlenecked on my ability to code up stuff that I was thinking about all the time.
Yeah.
And on the other side, there's Giulio that worked on Paperbench, and a core thing in Paperbench was structuring the actual papers that were supposed to be reproduced as trees, so which are a special case of graph. So basically we started in November, and by end of December we already had an MVP, and then we started raising money because it was very clear to us, especially in December, that the models were getting good enough to carry out experiments for a long time, and that the future of research would be mostly autonomous in the next few years. And we felt like definitely. So when we got in, I think it was February or March that Autoresearch came out. we had already been thinking quite a bit about the problem. And so as soon as, Karpathy then polished his own and published his own, take on it, it resonated so much with us, like what we're already doing. And I think that it definitely, we then decided to immediately land on with an open beta. I mean, I think we came out 1 or 2 months early. And actually, when we came out with the open beta, we didn't have the money in the bank yet. I hadn't finished raising money, I think, or maybe we just had, but we didn't have the money in the bank yet. And so it's been, let's say, most of Flywheel was done before raising, and it's becoming, and we're about to, accelerate a lot now.
You mentioned about Julio. So basically, for the people who don't know, so he's a co-founder in Paradigma, and he was at OpenAI preparedness team. And he's first author on Paperbench, basically the benchmark where AI agents have to replicate 20 ICML Spotlight and oral papers from scratch, and more than 8,000 individually gradable tasks. He also contributed to Emily Bench as well, and as SWE Bench verified. So that's pretty specific expertise, right? Like evaluating whether AI can actually do research. So how did you two connect, and what made him leave OpenAI to build this? Because it's a big call.
Yep. It's the story of how we met is actually pretty funny. Is we were mutuals on Twitter, and we had zero clue that we're both Italian. Neither of us knew at all, and we didn't know that we both live in the same city, Rome.
He's from
yes, Rome. He's Italian. Yes. And basically what happened was that I was organizing a local meetup for the first time. I actually organized the first AI Tinkerers. I don't know if you know the format in Italy, and it was in Rome. And he showed up, and when he applied, he had his X handle in the application, and so I clicked and I saw him. It was him, and I was super surprised. And I texted him immediately, and that's how we kind of met. And then basically, what happened was he noticed that I always had this, and it's kind of why I kind of got a following on Axis. I was always kind of tinkering and doing a bunch of experiments on transformers, and then sharing the stuff that I was seeing and my takes on it. And basically, what happened was I had a bunch of ideas, and my main bottleneck was my ability to kind of write the code and babysit the runs. And so he was like, I think we should kind of build some infrastructure to help you so that you can just think about the ideas and make sure that the rest is kind of autonomous, and you can keep track of what you have. And I mean, I'll show you later, my Flywheel graph is pretty large now. And I mean, there's quite a bunch of ideas in there. But basically, that's kind of where part of the idea came out. And then a lot of the design came out of kind of our own understanding, and of course his own understanding of the space, which I mean is changing a lot. Like really, our mindset before Opus 4.5 was very different, I think, and it's gonna change again. But yeah, the main motivation, just to give you like what really made us feel like we're going to start is, it was pretty obvious that software engineering was getting automated. Pretty obvious. And what happened was there was a time before when instead we're copy pasting from the web UI, from ChatGPT web UI and pasting it in the IDE, right? And then Claude Code came along, and kind of the scaffolds came along, and the right models came along. And instead, in research and in science, we are still in the copy paste phase. That's the main thing. And so we have to build the, let's say, infrastructure and the scaffolds and the models that will make that autonomous in the same way.
I was curious, like given Julio's deep experience building research evals at OpenAI, so are you building in-house benchmarks for Flywheel as well? And what would a benchmark for autonomous research infrastructure even look like?
Yeah, that's a very good question, and we are. And it's kind of one of the main things that we will be working on. Because, on one side, so the focus of the company is automate research. One step of automating research is build the infrastructure so that the models have something to automate research on, right? It's kind of load bearing. That's what Flywheel is. But there's an entire other point, which is if you try today to do auto research, you will quickly find that the models have very bad ideas.
Mm-hmm.
It's pretty obvious. And the reason we think is that the models have bad research taste. And research taste means basically, given the current situation, which experiments do you pick, which hypotheses do you make, which questions do you ask?
Yep.
Paradigma will build models that have great ideas and that have great research taste, and we're working on it. And the first step of it is building evals for it.
Yeah.
And so building a way to measure research taste, which is really hard in the sense that it's very open-ended. It's really kind of fuzzy, even in a way to define it. And so, yes, we are working on this and expect to see something soon about it. And I think yes.
Mm-hmm. Go ahead.
No, I was saying, I think one of the first things we will kind of also publish and work on in kind of more in public is a more formal way of evaluating what we call auto research in the sense that given a very open-ended problem, what do different models with different scaffolds, how do they behave differently in tackling it over a long period of time?
Makes sense. You mentioned about research taste. So on a high level view, can you mention 3 pointers what actually comes for when someone talks about research taste? What you really look for if someone is going for research, and how research should go for how someone can actually run experiments end to end, and what you really mean by research taste? Let's say if you have to kind of give an instance in 3 pointers or so.
Yeah, I think I'm not sure I can make it into 3 points, but research taste is what differentiates a PhD student from a PI, a principal investigator. It's something that you learn, actually.
Yep.
So think about it this way. Every time that you're starting a new project, you have some constraints. So you know that you have just so much compute, so many ideas, and you can go in so many directions. And taste is kind of a probability distribution, it's a prior over which direction it makes more sense to go, with the objective at the end of, having good impact in the research so that the research is successful. And so a very good, very, very tasteful person will come up with a great research direction that nobody thought of and that works very quickly in a few steps and builds great impact. And so would basically be, pick the correct question. That question has to lead you somewhere impactful and do it quickly. That's the main thing that kind of gives you taste, I think. And I think that it's the main thing humans will be responsible for a while.
Yeah. And
if you're a student today, you should be definitely refining your taste. And you can. That's the cool thing. You can.
That sounds good. So if you have to compare how good these models are becoming, so how do you what's your taste behind models just about research?
Yeah, I think so there's a core belief in Paradigma's research thesis, which might be wrong, but it's this. There's somewhat of a trade-off between being a very good assistant and being a very good tasteful ideator. And so current models are really great assistants. And they are, and they have to be. They're built to be.
Yep.
But unfortunately, we think that being better assistants makes them worse ideators. And I think it's very obvious because the models will tune hyperparameters forever. Or they will definitely circle around the same kind of safe ideas. And that's kind of, if you think about it, part of being contrarian or not. Great thinkers, great ideators in the real world, great scientists are usually contrarian. They kind of want to go against you, against the establishment, right? And I think that the models are getting better because they understand your instructions and they understand what a creative person is. But I think that the way that we train models today is structurally very resistant to building very creative models. And I think that there's not too much, the models are not improving at the rate that they're improving at other things. when it comes to taste.
And I think an integral addition to this notion of thought is LLM psychosis as well. They kind of start agreeing you what your kind of observation with what your thoughts are. And I think it's very subjective take, but a lot to do, because I think because it costs you resources, it costs you compute, and you have to be really aligned what direction you have to go. So I was curious, you mentioned about so basically for those who don't know, Paradigma has chief scientist Emmanuel Rodola, who is full professor at Sapienza. He's an Alice Fellow, ERC grant recipient, over 14K plus citations. And his Gladia lab is the first public adopter of Flywheel. So my question is, how does a research group use Flywheel differently from how an agent or an individual uses it?
Yep. Great question. And I think it's the key to why it's useful. So think about it this way. In Gladia, everyone was already using models to do research.
Mm-hmm.
It's obvious, but I mean, all serious research institutions are doing this. The point is that the models are mainly accumulating knowledge for the single person. So it's like this private conversation that each person has with the model. And then that person is kind of responsible to use kind of these, let's say, traditional ways of communication, to communicate that research to others. I think Flywheel definitely flips the script on this, and it definitely does for Gladia, in the sense that now the people are pointing their models towards a shared thing. So they're all looking at their graphs, and they're all working on it at the same time. Yeah. And that's the first benefit, is simply collaborative structure, which is something we're finding very useful. And then another thing is, so if you had to be a PI of a large lab, I mean, Gladia has 30 people, you have to kind of keep an eye on everyone, and you need to figure out, and the way they were doing it before, it was like on a Discord channel. I mean, they still have it, but it's a very kind of, it relies on the person's memory, and the person is building in their head a graph that contains everyone's experiments. And now you don't have to do this anymore, and you can focus really on your ideas and spend your time on allocating the resources where you want them, because you can clearly see that someone's graph is not growing, or you can see that the experiments they're doing don't make any sense. So you can ask your own model to go check that graph's or that node's experiment, and then assign a comment on it, for example, and that makes it much smoother. And I think in general, even if for people that don't work in the same group, I mean, it's cooler if you work in the same group, but even if you're collaborating with a bunch of friends or with other people, it's actually very much more useful than sending, a whole bunch of papers one way or the other, because it takes a long time to read it, and you're relying on people's memory with it.
Oh, makes sense. My question was, Gladia adapted first about what the concept of Flywheel is. What genuinely felt like, apart from Gladia, what was first external validation for Flywheel? I mean, which really made you mind blown?
Yep. I think there's quite a couple things. I'm not sure I can make names, but there's people from very cool labs that reached out and basically told us that before they were handling experiments in a very traditional way.
Yep.
Which I didn't expect. And instead now they have a graph that contains their work. And I mean, that's a first thing, let's say public external thing. And the cool thing is, I think the coolest thing of Flywheel is that since it's basically a way of kind of building the scientific method into a tool, because every experiment is as a hypothesis, as an experiment, every node as an experiment, basically it generalizes across disciplines with the model's knowledge. So, for example, there's people who are trying to work on the Riemann hypothesis using it.
Yeah.
Or there's people that are trying to work on quantum cryptography. Or there's people that are exploring bioinformatics. And so the cool thing, I think, is that now those people can look at other people's graphs from other disciplines and completely, and transfer the patterns. And I think more practically, for example, we're using it to build our own infra. Because as I said before, we're going to be training. And a lot of the kind of work and job of building that infra is a lot of testing and a lot of figuring out what works, what doesn't. And Flywheel is great for that because you can record everything, record all the configurations you tried as a graph. And the model always knows how to read it. And it comes very handy, even though you're not really in a research problem. But anytime you need to experiment and record the kind of exploratory experiments that you're doing with something, it works. For example, my flatmate is not a researcher, and he's using it to test out the front end of his app, for example, and he keeps like images of the various components, and then chooses the one that he likes later on. And so I think the main validation out is that I've seen is use across disciplines. Yes, so cool.
Awesome, makes sense. I think okay, so maybe we can traverse through Thesis now, and in your essay, it mentions that when intelligence scales, structures become everything. So, I mean, in your essay, the new age of research opens with this line: "Every hard problem humanity has not solved yet is at its core a problem of insufficient intelligence applied for insufficient time." So can you walk me through that? What kind of hypothesis you have for that, and how do you really think of this?
Yep. I think it's really the main thing that motivates us to make this into a company, because this could have been an open source project, or it could have been a personal project, it could have been anything. But when we look 10 years down the line, when we look 50 years down the line, something becomes very obvious, at least to me, is that basically, the very, very, very big problems that we have as a species, think of like nuclear fusion is an example, or building a Dyson sphere, like things that are out of our imagination. They do depend on how many people are thinking about them. Yeah. Right. If how many people can efficiently organize their thoughts so that they work towards that goal. Right. Yeah. And so basically, it became very obvious to me that in 10 years' time, it will be a risk that people do it and not machines, because it's just for the opportunity risk. Right. If you could have cured cancer if you just had more GPUs running, you're effectively putting us at a risk if you're not doing it, right, in a sense. And so that's, I think, what motivated the company to be a company, is that one day this bottleneck will move from humans to compute. And it's already starting. I mean, you can definitely see it. Is that the humans have to be bottlenecked on the most amount of value that they can bring to their research, which I think is the ideas, not really writing code anymore. And in the future, what I'm seeing is that we will have we'll be a little bit different. Like, I think that the way we see science today is something that we kind of pay a lot of attention to. Like, you imagine the scientist is paying a lot of attention to the problem he's solving, right? I think in the future it will be much more similar to having some infrastructure that you set up and you build, you manage, you pour computer into it, and you kind of mine the results. So you kind of have this machine that produces a map of the knowledge of the world, and kind of and it becomes a problem to explore it, to explore what you found and figure out if something is really an important problem. And imagine having that happen with the speed of thought and artificial thought. That means, I think, in the future that we will have thousands of industrial revolutions a year. And so the bottleneck will be our ability to maybe implement it in the real world. But the breakthroughs that we've seen in the last 100 years, which are mind-blowing, like think of quantum mechanics and variable relativity and electronics and everything and the internet, all of those will happen every day, or things of that scale, right? And so it will be a problem of finding those breakthroughs and monetizing them and building infrastructure around them in a way that makes them reproducible, that makes them extendable. And that's the way I see it. Yeah.
Totally makes sense. Only thing I kind of been curious about is about its scale. So, what's your observation of like, let's say, top five labs? Let's kind of think about it. Uh, Out of top five labs, how much is the adoption of scaling auto research in their internal kind of loop? What's your observation? How is it scaling? Like, are people adapting to this approach? Because there are a lot of stuff going. Today itself, Minimax M2.7 being launched, and they have also did some self evolution. They were also training some ML models as well, which was iterating a lot and performed really better. So if this is the case, how much do you think, like in next 6 months, we really do have an auto research loop? Because I think the whole economy might change with this, and this is very pivotal step for labs, and labs are, you can say, the frontier of the technology now. So, and it will followed by the other subordinates as well. So what's your observation about this?
So first of all, I think that auto research is more here than we understand it. So what I mean is that we're very early in terms of human psychology, and of acceptance of auto research. Also, like, by the way, like also in the, let's say, early adopter segments. Like, I'm not talking about regular researchers. I'm talking about like in the loop researchers. I think very few people have really thought about autonomous research and what it means and the way they should best use it, I think. But I think that in some specific pieces, and we're seeing this with the labs, people working with the models are kind of forced to go and find out the best way to make it work. And I think it's going to be very obvious that is going to accelerate development so much. And I think that the cool thing is that at some point everybody is going to realize, because there will be these very tiny niches of technology that start taking off, and there already are. I mean, look at the release speed of models, and look at the people that are in possession of or of the capabilities of using auto research structurally. The amount of results that they can get in so little time. I think there's going to be an effect in which everybody realizes immediately, like somewhat sharply, and then the adoption starts, and kind of best practices form around it. Because one of the things that we're noticing is that those don't really exist yet. We're trying to bake a bunch of them into Flywheel. It's difficult because we're still exploring, like in the middle of everyone else, the way that works. But the way that I think about it, I think it was Francois Cholet that mentioned this in the first place, is that we need to think about auto research somewhat as a kind of optimization algorithm of its own, and that can overfit, that can have a bunch of that must be regularized, and that can have a bunch of different problems that can converge faster, converge slower, and I think that we're going to be building in the future a whole theory of how to do that and how to properly build an auto research system, and how much to explore, how much to exploit individual directions, and how to structure that. And I think Flywheel will be a core element of that, because it will provide the structure to do this kind of exploration.
I really want to understand the whole, the idea behind Flywheel. So, let's start with the simple notion what people really think about this. These models are scaling with an order of magnitude now. Like, we started with DeepSeek V3, then R1, then OpenAI come with O1, and then we have Sonnet, Opus, and a lot is going with 5.4. People are like doing incredible things with these models. So in this auto research loop, let's not talk about the capability of model itself, because that's absolutely gone up in the loop. What are other things which is making the concept of Flywheel, right?
Yes.
And what really separates it from the model capability and making the auto research loop and the things around it incredibly, you can say, exciting, or separable, whatever?
Yes. So when it comes to Autoresearch, really, the way that we think about Flywheel is that it's somewhat the it's the engine the Autoresearch runs on. And so the point is this. So I think there's a lot of, let's say, not confusion, but there's a lot of attributing of Autoresearch to the Karpathy Autoresearch, which is great.
Yeah.
But the Karpathy Autoresearch, if you think about it, is like in Flywheel, what it will look like is kind of a single line graph.
Yeah.
Right? In the sense that you have one experiment at a time, one after the other, and then in every node of the graph, you're moving, to a new change that you've made. Of course, that's great, I think, and that's, for example, something you would use, and that works in a bunch of problems. But the cool thing about Flywheel is that it generalizes this. So what you could do, for example, is if you use Flywheel Auto, is you can set it up so that basically the model plans 1, 2, 3, n steps ahead. Yes, we can do it. Yes, we can definitely do it. We can definitely do it. Let me share the screen. So first of all, this is my my graph. My Flywheel, and I mean it's pretty big. And there's this is a very large one here. That's the Autoresearch campaign that we did.
Explain if you can talk about every such component here, that would be great.
Yes. Let me start from the very beginning, so it's easier. So basically, this is the first view that you see in Flywheel, and what you're seeing here is two things. So on one side, you have kind of this closed circle, which is your private experiments. Okay. You can think about it as your own private repos in Git, right? And then outside, you have the public ones, or the ones that you share with other people. And for example, here there's a very large one, and this was an Autoresearch campaign that we sponsored, and so there were quite a few people here that were at the same time participating and working on, improving on NanoChat. And so, for example, each of those nodes is a specific experiment. And if I zoom in, you're going to see that, for example, each of those is an attempt. And so, for example, this was using attention residuals, right? And so, the entire point of Flywheel is that it structures the experiments, as we talked about, as a directed acyclic graph. So I think this is a great example in the sense that, for example, this graph was an Autoresearch campaign. And in the Autoresearch campaign, you have, you can set up rules, and you can, for example, have a leaderboard as well. And maybe this is the root node, it's in white. And here is the root node. The way that you use it is you usually kind of use it as a README file, as in Git. And in each one of those nodes, you can type stuff. You can have, in this case, it's just a banner, but you can have the artifacts that might be, for example, in this case, some Autoresearch record progression that we had. And I mean, this is the root one, but if we go and take a look, for example, at some more involved experiments that have been done that are, kind of experimentally kind of neater. Let me look for one. For example, this is the Pringle paper from Gladia. Is one, I think, the first paper they published on Flywheel. And for example, there is an experiment about collisions in representation in the in the models, and in here you have all the artifacts, and connected to this you have also the repo, of course, that kind of are the results of their experiment. And basically the way that this works is that as you talk to a model, and I will show an example of this now, these things are tracked autonomously. So the model already knows how to structure its own things in the shape of these kind of graphs. And depending on kind of the problem that you're attacking, the graphs can get pretty crazy. Like if you look at this, like these are some of my internal stuff, and you can see this gets pretty crazy. Of course, we're still in beta, you can see. So we're still working on the UX. I mean, when the graphs get really big, it gets a little messy, as you can see. It's something we're actively working on. But let's jump into it. Let's try it out. And for example, I have a bunch of experiments happening. But one cool thing that we just released is the two graph skill. Because one thing that you can do when you install Flywheel for the first time is you can two graph something. So what Flywheel two graph does is it transforms something into a graph. And basically it might turn a blog post, a paper, a repo, anything into a graph that you can then start working on. What you can do is, for example, say, let's turn this blog post, which was my blog post on attention sinks. This blog post into a Flywheel graph using two graph. And what happens is basically that I've already installed the Flywheel MCP on this machine, and I have it connected to my codex. And the model is going to understand the skill and is going to be connected to Flywheel to, for example, do this. And in the meantime, the cool thing about Flywheel is that I can run experiments. So, I'm doing this on Flywheel, and since it is via my MCP, I just start a new chat with Codex and be like, let's use Flywheel to do a small toy experiment on an MLP. Use Flywheel compute. And basically, what he's going to do now is going to be, first of all, writing the code for the MLP experiment. But the cool thing about Flywheel is that we have credits and we have connections to a bunch of different companies that provision compute. Prime Intellect, Lambda, Nebius, there's a bunch of those. And what you can do is you can use basically the compute that we provision to run the experiments. And so he's going to be using the GPUs that you can get, and autonomously provision the right GPU that you think is good, and then he's going to be running it and saving the results and producing one of these graphs. Of course, this is going to take a while, but in the meantime, maybe we can take a look at something that I've already done that is public today, and it's maybe a little more involved. And for example, yes.
So every experiment is a node here in a DEG, and there are two types to it: insights, which is basically theoretical, and empirical as well, which is testable with a hypothesis. And every node tracks what it extends or contradicts. And branching creates parallel paths. Merging combines findings. Application is structurally identical to branching. So my first question is, why are DAG specifically? What structural property makes it right for research over a tree, or let's say a flat log? It's a very fundamental question, but would love to know your thoughts.
Yep. So there's definitely, we could get technical in this, in the sense that, there's a DAG is a pretty general structure, really. And the interesting thing is that, the point is, the simplest thing would be a tree, but you also want merge. And so that's DAG basically. But I think there is even more intuitive one, which is, think of the operations that you do when you're doing research, right? You're thinking of a bunch of things. So you need branching, right? Because a bunch of experiments at the same time. And when you do a new experiment, as in these cases, right? Like imagine here, look at this. Like here, I think it was a sweep of some sort. And I did a bunch of different branches in which I tried a bunch of different configurations, right? And each of those is an experiment. And for example, in the same graph somewhere, at some point, these different configurations are going to take you to a single conclusion, right? And so they're going to be merged. I don't think this is actually merged. Let me find one in which it's easier to see. But for example, like if I go on the mixed curvature experiment that I'm doing, that I showed also on your scenes, which is a significantly bigger one, right? Basically, here I had a bunch of different clusters that were each doing something. So there was a part of the experiment that was doing theoretical sweeps on their architecture. Not theoretical, but they were doing experiments on figuring out what the best architecture was. And then there was on the other side, an entirely different cluster that was doing optimization of the kernels to make it run fast. And so then we had to merge the two things into a final recommendation, right? And so you also want merge, and then that's all you need in a sense, right? And that's what a DAG is. And if you think about it, it's also the way you do research. When like in your mind, if you had to draw out what you've done, you would probably draw something that's similar to a DAG. We don't think it has to be this way necessarily. Like maybe in the future we'll figure out that we need something else. But so far, I think it's very intuitive, and I think it's the most intuitive thing. Like everybody tells us, "Oh, DAG," it makes a lot of sense. So
makes sense. Like I just had one question here. So when a node says it contradicts another node, right? So what really happens downstream? So let's say if node B contradicts node A, and node C was built on node A. So does the system surface that tension automatically here?
So we haven't. That's one of the things that we kind of struggled with at the beginning. So if I understand your question correctly, you're asking like, is there an underlying mechanism that kind of forces
when it
them?
Comes to dependency and how, like when it comes to dependency and the result, the conclusions we are actually running with. So I just want to understand the internal mechanism here. How does it operate?
Yep. The point is this: it's like it's not that mechanical. We at the beginning it was, and we wanted to make it very mechanical. But if you make it mechanical, you basically produce either a system in which you have to enumerate all the possible stuff that you can say or can write, which is very constraining. Or basically you make it impossible to use it. Like you can only do just a few things. And what happens is basically the way we think about it is the models are responsible for that side. So the graph is the place you accumulate the understanding, and you accumulate things that may be contradictory. And the model has the responsibility of producing a graph that has the structure that encodes and reconciles that contradiction. And it's something that's going to be, let's say, horizontal across Flywheel, is that the models will still have a lot of power in a sense. They can do a bunch of stuff with Flywheel. It's not very constrained.
Yeah, makes sense.
Yes. I think
experiment kind of done.
Yes, I think so. And of course, he said, wait a second, let me find what he did. Yes, for example, so he turned my blog post into a graph, first of all. So that was the first thing I asked him to do. And so basically he has, he also extracted the first image, I guess, and then makes, different sections and logical, logical connections between, the different parts of the blog post. And for example, there's a bunch of way of visualizing this, by the way, in Flywheel. And one of those is double click in. And if you double click, you move to the node you double clicked on. So I think it's very convenient. And this was done at the same time as the MLP one, which is still running, I think. Yes, on managed compute. And yes, it's experiment brief and it's still going. I think, yes, still running. But the cool thing is that I usually have 5 or 6 different agents working on different experiments or on the same experiment at the same time. And I can do things like these. Like, for example, on one side, I compile the literature and put it in a graph. On the other side, I have the agent read that and implement that, right? And basically what happens is, you're going to see it, but the way that you get these giant graphs isn't by manually doing all the experiments. It's and your job becomes more that of kind of being a general. So kind of being the person that figures out, okay, this side needs some help, needs some compute, needs some understanding, and you direct it there with your agents, and you fill out like the kernels that you get, for example, you get better speed on your ops, or you get lower loss with a better architecture. And as soon as this is going to be done, is going to be, we're going to see it in a few minutes if we make it in time, but it's going to be similar to those graphs in which, you have a final, let's say, artifacts that proves that we've we've trained the model. I don't know if you have any further questions in the meantime, or
Basically, yes. There was one more question I was just curious about. So this basically it's a graph. So when does the graph get too large to be useful? Is there a curation problem as it grows? Because there's a lot of I think exponential addition being done here with the graph.
Yes, definitely. So there definitely is the risk. Let's take a look at a very large graph. The Autoresearch graph I think is the largest we have public.
Yep.
And I think it's 200 nodes or something.
Yeah.
So one of the key things that happen is that the models get very constrained on context, of course. But kind of the point of it being a graph is that you can use, it's kind of in an RLM fashion. You can use the topology of the graph to navigate it. And so the point is you only need like a constant amount of information to be able to get anywhere on the graph. And so basically in the perfect flywheel, how large the graph is will not really matter, because the model will always understand the topology very well and will always be able to transverse it and find the right thing to work on. With that said, there's a lot of work that we're doing in producing graphs in a way that they're the perfect amount of kind of compaction of what happened. And that's not easy to do, of course.
Yeah.
And so very large graphs to this day are a little more difficult to work on because the model becomes confused at some point. But you know, that's also resolved by asking the model to only care about a piece of it and not.
Makes sense. Totally. Do we have the research done?
Not yet. I think it's still working on it. Yeah.
Let's keep it running.
The run itself succeeded.
More questions, and we can basically come on later as well.
Yeah. I mean, do you want to ask any other questions? Yeah. Sorry. I don't think I understand.
Surely come later as well.
Yeah. I think it's so. For example, he's done with the experiment. I think he's committing the results as we speak. So maybe we're gonna see it live. Possibly. I'm not on my usual setup, so I usually have a much larger screen that I can use those two at the same time.
I can get it. Yeah.
Because I'm back on my. So for example, he's preparing the upload of the artifacts that he just produced, and he's going to be putting them in here. And I mean, you know, this can maybe seem a little slow in the sense that, you know, it's a toy run, but I mean, this is the way that it works in the sense that it's a little bit of a warm-up period in which he has to take the machine and install stuff on it. But it becomes very, very useful instead when you're running long-running jobs, and that part is kind of negligible. And the point is, you know, being sure that you have everything around and know that you're doing the right experiment. Let me see. Yeah, and there it is. He gave us the results, and basically he has, I think he gave us our uploaded media left in node creation. I think he's still uploading them. But yeah, he did the experiment. Let me ask him.
What do you think of this technology we are living right now? Like just prompting, getting results, no such manual.
Yeah.
Because I remember like 2-3 years back, like even just like a couple years back, we used to type everything, import transformers like from there and everything. And what do you think of the technology, and what do you really see in couple of years we are heading to in terms of, let's say, Autoreserch or something like that? How Flywheel will be in, let's say, 2 years down the line from here?
Yeah, I think the point is, think about it this way. As you just said, we're at the beginning, we were like not even typing stuff, like we were building the computers.
Yep.
Just a few like decades ago, right? And then we were typing assembly in it, and then we're writing Python, and then and now, you know, kind of your job as a researcher becomes more and more abstract.
Yep.
So before AI, I was working on one experiment at a time. And after AI started working, I was like, okay, 2 or 3, but still the same main project.
Yeah.
And then, it became more and more massive. And so now I'm working on 5, 6 projects at the same time, and each has like 10 experiments at the same time. And so my activity becomes much more similar to kind of an orchestra director, right? An orchestrator, if you will. And I think that this will continue to abstract over time. And basically what happens is, we will look at things from more and more of a bird's eye view. And in 2 years down the line, we'll be picking entire fields. We'll be picking entire 1-year R&D projects from companies, and we will be, completely resolving them by just putting compute in it. And we will be completely, and I mean, of course, these come out with the results as well on here, but I think this should be also on this. Unless he had trouble uploading them, I'm gonna ask him. But the way that I see it working later is people are going to be defining scopes. So they're going to be defining where the model doesn't have to go and kind of where it has to roam. And then we will take a look at the graph from time to time and direct it somewhere. And then at some point, we're going to have the result that we were waiting for and then check it. And a key part will be a good way to check. And it's something we're building into Flywheel as well. It's kind of similar to the way that humans do it. The way that humans, check research is basically by, rerunning the experiment and seeing if it checks out and seeing if the result is the same and reproducing the experiment. And we need to do it at scale. We need to do it with the same speed that you're coming up with experiments with in the first place. And we're already not doing it like in the humans way. We're not doing it. But one thing we're building into Flywheel is that we want to build consensus so that and incentives so that those graphs that are more impactful and more true, which have been, kind of reproduced more, become more visible and become more of an authority for us.
Yep. Awesome. I got this question from on Twitter. How Autoresearch will scale from doing autonomous to paper-oriented research, meaning the agent reading papers around the topic one is working and finding practical improvements that can be done to pipeline or process like at a time reading and papers, finding convenient and suitable changes and running them. So what do you think about this?
So I think, first of all, if you think about it, the existing auto research mechanisms can already do this in a sense. Like the models have access to the web and can read the papers, right? And kind of incrementally, improve things and then transport patterns. The point is that the papers are very kind of token inefficient, right? Because they're meant to be read by humans and have kind of all the little narrative things in them and to be convincing and right. And basically, I think that, a lot of improvements will actually come from just cross-pollination of existing patterns from somewhere else that are very hard for humans to kind of dive into. And it's also something that I write on the blog post is that, for humans, it's very hard to be a researcher in 2 very different areas. It's not very natural, right? For the models, one of the cool things about them is they're very general. And so you can actually have frontier level research in multiple domains and understand about the way that those things become interdisciplinary. And I think with Flywheel, this will go even further because at some point, one thing we're working on is taking as much existing science as possible as a public graph. So Flywheel, instead of just public graphs of people uploading, will be filled with existing works. And the cool thing is now, instead of having to read every paper, what you will be able to do is kind of take a pattern from that paper's graph and maybe take just a subtree or take maybe just a couple of experiments and then transport them into a new research they were doing. And kind of this is also the way that I see the use of Flywheel working, but also in general, Autoresearch. Like the way that I see it is, people start individual different projects, and they grow them. They grow them like little plants, and by growing, those projects slowly intertwine because it becomes very clear that maybe they're attacking something similar, and then they're becoming necessary one for the other. And so there's like this project symbiosis that connects them. And in Flywheel will be like graphs merging and things. So our research, the way that I see it going forward, is also a lot about cross-pollination and growing together.
Makes sense. Totally. So before we go ahead to the next part of the pod, these are some basically quick fire questions. You can answer them maybe in a line or so. So the first question is, most broken thing about how research is done today?
Most broken thing is, good question, inappropriate use of LLMs, I think.
Oh, inappropriate. Okay.
Inappropriate.
Yeah. And biggest misconception about autonomous research right now?
Biggest misconception is the model has to do it all.
Mm-hmm. Oh yeah, makes sense. And my last question would be, if you could automate one part of the research process forever, which it could be?
Yes. I think it would be CUDA debugging. No, but if you want to be a little more like generic about this, I think it would be, in my case, it would be definitely the engineering side.
Makes sense.
Because people should work on their ideas. It's better. It's cooler.
This question I got from Token Binder about you. So how are you approaching exploration for autonomous research in general, and what do that think about the toughest ideas to explore for these models that may not be cream of the sampling process? And what does you think about the toughest auto research challenge as of today?
Yep. So there's a couple questions baked in this. I think, first of all, let's say, as I was saying before, exploration in the models is tied to research taste, right? Autoresearch is, as we said before, kind of this new optimization method, if you think about it, right? Mm-hmm. And one of the parameters that you can look at is how much are you exploring, or how much are you exploiting, right? And the way that we encode this, for example, in Flywheel, is that you can set the amount of things that the model think kind of at every step, has to consider. For example, has to consider at every step like 5 different things, or 3 or 1. And so that's one, let's say, outside thing that we're working on. That's built in Flywheel. It's kind of part of the harness. It's part of the skills that the models has, and you can kind of have a little bit of control over, how much does he plan, how much does he go in width, right? When it comes to, instead actual interventions in the model, I think there's 2 different directions. So one of the first things we will try, and we're trying, I'm not sure we're going to release this we're only going to release it if it works. I don't know yet. But sampling is very, very interesting for us, in the sense that I think there is some wiggle room to sample your way out of, more interesting levers than just temperature for making the model a little more creative. And it also reminds me a lot of Entropics. I don't know if you remember the Entropics project by XJDR and Doomslide. But that was a cool thing that I had the luck of kind of participating in a little bit at the beginning. And that's something that I think we're going to be definitely be trying, but it's not our objective at the end, because I think that the real difference will be in the weights. It will not be some kind of external intervention, or it will not be some kind of scaffold that really makes the model more explorative, but it will be finding an objective and a post-training method that makes the model naturally more explorative. And it's not really about with respect to the current model, it has to explore more because the current models explore very little, but it shouldn't explore too much. So the way that we think about it is that kind of the base models are kind of schizophrenics, and the current models are kind of, like hyper-focused on one thing, and we want something that's has taste. So taste is picking the few directions. So still focus, but the few directions that make the most sense. And the base model picks every direction, and the assistant only picks one that always picks. And so I think it will be a training problem.
Out of all this, which model do you really think has good? I'm not sure if I has to say research taste, but at least which has the enough capability to explore research directions out of all the models you have kind of tested, you have kind of explored so far.
Yep. I think I really like Sonnet 4.6, and I like Opus, but I'm not entirely sure about Opus. We don't have benchmarks, so this is vibe. Okay, this is not formal. I think GPT models tend to explore it less, and one model that I really like are the Kimi models. And yeah, sorry, you wanted to ask something? Yeah, I was saying that I think the Kimi models tend to be more explorative. I think it could have something to do with Muon being in like the optimizer that's used. That's something we're actually working on in an experiment internally, and I'll say more about this when it's done. But we're trying to figure out if there is qualitative effects in optimizer choice when it comes to these kind of things.
I am getting a kind of vibe. We can see some good open-based model which is good in exploring ideas from Paradigma.
Could be. It's definitely something we're thinking about. It's the way that we think about it for now is that the first models that we will release will be post-training from existing models, just out of a strategic element. But we're actively thinking of, does pre-training really matter? Because it's not obvious, right? Like It could be that it's all a matter of post-training, but if it ends up being something useful for like pre-training from scratch and being useful, we definitely want to go there in that case.
I mean, yeah, totally makes sense. Let's go on the broader landscape. A lot of people are working on this from different angles. Basically, the Autoresearch thing, like Karpathy has done. Sakana AI scientists published in Nature, end-to-end from hypothesis to paper. And Future House also builds biology agents funded by like Eric Schmidt, if I remember. Google has AI co-scientist on Gemini. LSA does AI-assisted literature search. And now dozens of auto-research folks already existing, right? So where does Paradigma sit? Like you're not the researcher, you are the infrastructure. But doesn't that mean you depend on how good the agents are?
I mean, in a sense, yes, definitely. Mm-hmm. And of course, all of those companies and the projects that you mentioned I think, will be key parts of the infrastructure.
Yeah.
I mean, infrastructure only makes sense if there is models using their intelligence to figure stuff out. And the more companies go in the direction of building those models, the better for us. I think that and of course, we will be building those as well. We will be training models that work very well in Flywheel. That's the thing where we want to work on and come up with great ideas. Simply because we think that it's going to come up with a lot of economic value, because one of the ways that we want Flywheel to work economically is monetize what comes out of the scientific results that the models discover, and it makes it, that's an investment. If the model works much better with it, it's an investment that's interesting to make. With that said, I think that with respect to the rest of the environment of the landscape, I think we're the only ones that kind of publicly went with we need a new science paradigm. I don't think others did. I think everyone was still thinking living the same scientific paradigm as before, and then with just better intelligence or faster intelligence. The thing that we're very proud of is kind of being the first in proposing a way of doing science that scales within model intelligence and doesn't break under its weight. And so that's how I would position Paradigma, yes.
Makes sense. And I really believe if this works, the more shifts from who has the best model to who has the best structure for turning intelligence into cumulative knowledge. Do you also believe that?
Yes, I definitely do, because the two things need to go in tandem. Because of course you can only build a great structure if you have a great model, and so that's going to be key, of course, anyway. But once you have that, and there's going to be a bunch of those, right? The point is, can you extract the value out of it? Can you show that a discovery makes sense? And can you use other discoveries to make more discoveries? And that's what we think makes an infrastructure play a great play. And yeah, happy that other people see it this way. Yeah.
I'd also thought, and I've been part of some discussions where people believe that auto research is also a very trust problem, because agents might hallucinate, they can exploit metrics, they can produce results that look right, but that are not. So, what's the right verification layer here?
That's a great question. So there's, I think, so think about it this way. We kind of, as humans, figured out a way of verifying science, right? Which is having an adversarial scientist that to some extent reproduces the result. And it's baked in the scientific method, if you think about it, like a claim has to be falsifiable and it has to be reproducible, right? Because if I cannot reproduce your result, independently of how good your experimental setup was, you cannot claim that it's true, right? We're sharing an underlying reality, and so it has to be the same for the both of us. And so I think that's one great thing about science we figured out, and we're gonna be trying to have that in Flywheel. And so I think that's the best verification will never be like an exact type checking, or it will never be an exact mechanical element, just due to the sheer combinatorial load of doing that. It's impossible for you to exactly check everything. You can do that with mathematics, for example, with lean. So that's something we already have. You will find some papers that use lean in Flywheel, and it's very useful. And there is also a Flywheel skill to prove stuff with lean. But the way that we think about it is people will be able to kind of commit some amount of compute to reproducing experiments and graphs, and that reproduction will kind of award them with some little ownership, like 0.1% ownership of that knowledge, of that graph. And the cool thing is that we kind of want to incentivize it so that, think about it this way, think about attention is all you need.
Yeah. That
paper is like $1 trillion of valuation, like, right? And if that was done on Flywheel in the future, in the next year, possibly, what it will look like is everyone reproducing it. And so it becoming a very cool paper that everybody's reproducing. So it's very visible. And many people that spend some compute to reproduce it own a little bit of it. And they reproduced it because they wanted to own a little bit of it, because they thought it's a greatly impactful thing that can be monetized a lot. And now they will be able to monetize that their participation in making that a robust claim. And that's something we're still thinking about. It's not final, and it's going to come in the next few months and years. But the way that we're thinking about that verification is a soft one. And it shouldn't be rigid, because rigid is impossible. Rigid where you can, but it should be soft and scale with the models, scale with the agents, not scale with the human.
Yep. I was just listening you and got into this thought, like what people can do. So right now, what do you think of, we have Alpha Archive, where we have a lot of collection of papers, people trying out stuff. But I have two things I was just running on my mind. So what if Flywheel gets connected with Alpha Archive and people can just start running on experiment? This is one. And and the second is bringing collaboration as well, getting multiple researchers working on the same idea. So what do you think of, like, how it can shape up everything about the research trajectory and everything, and what the possible edges could be out of those nodes?
Yep, those are both things we're definitely thinking about. And I mean, I hope the Alpha Archive people watch this so that we can think about it together. But we definitely see, especially in transition period, in which every paper has its own little Flywheel link. And in the next few months, we will see the first papers submitted to conferences that we'll have, and some of them will be by us, that will have their Flywheel graph link. And yes, we think that the UX that you just described is incredibly cool in the sense that you could read a paper on Alpha Archive, and then you could see the graph and then branch off of it immediately. And so immediately do another experiment or immediately check it. And so that's definitely something we are thinking of and trying to make and build. And so that's definitely a direction we want to go. I think you said a second one. I think I forgot about it.
About collaboration.
Yes, collaboration. Yes,
multiple people, researchers, and everyone to work on certain problem and get out something.
I think we saw a first version of it with campaigns with the Autoresearch. We want to extend that, and it's coming very soon. It will be a work with Sinatras. I will not spoil what it is yet, but it will, and we will start working on some general, let's say, problems that everybody will be able to contribute on. And there will be, you will be able to, put your name on the record and be part of this kind of, community effort in solving.
That's great. If you can share thoughts about what's the business model here, what are the kind of workplaces, labs kind of you're targeting, and what you can really see people doing with this for, let's say, what's the plan ahead with this? Because I think it's been like 6 months now. And how is it going to be the next for the next 6 months? What can be the pivotal thing which can happen to Flywheel?
Yep. So the way that Flywheel wants to work. So let's start from the final direction. The way that Flywheel works in 10 years is we monetize the results of the science that we make. Mm-hmm. Very ambitious, right? But basically, we sell the results. So we sell the airframes, we sell the designs, we sell the patents, right? And of course, before you're able to automate the entire thing, mm-hmm. And monetize it as well. Mm-hmm. We kind of already have as humans a structure that monetizes innovation, and it's called companies, right? And companies are just that, if you think about it. And we want to be automating entire R&D processes in companies. And so there's quite a few very valuable points, we think, at least talking to the companies that we're working with at this time, is that, first of all companies have trouble with structuring their R&D. Like the managers of the R&D rarely have an understanding of what's going on, who's working well, who's not working well, who needs more help, who needs more resources, who doesn't. Flywheel is a very natural interface with that. And so it can very easily, come in as at the beginning, just a tracker of what's going on before automating everything. And then what it does is it sets up the infrastructure for you to automate it later. And when the models are good enough, possibly. And to do that, we're starting from researchers. I mean, we're still in open beta. We're still iterating every day, every week. And we're getting a lot of great feedback from great researchers from companies from all over the world that use it daily in their daily work. And that's where we're going to start, because we think that in order to convince companies that we're legit, we need to convince the researchers.
It's a great validation for the product itself.
Yeah. Yep, awesome. Yep, definitely.
I think we can, as we are kind of to the end of the pod, what do you think about the frontier right now? And what are some of the things you are most excited about? Irrespective of Autoresearch, but as the space in general, and what is something, pretty much you are kind of looking forward to?
Yep. I think we are in the age of research. Mm-hmm. So, I'm very excited because we will be seeing, I think, models come up with capabilities that still now, even though we think the models are very good, we don't mm-hmm. imagine. Mm-hmm. I think models will have extreme ability to do long-term tasks. And I think some companies are working very, very hard on sample efficiency of training a model with very few steps, very, very little data. And that will change a lot, I think, the rules of the game, because many people will be able to train models. And I think we will have, I feel like the GRPO local minimum is coming to an end, in the sense, not coming to an end, but I think we will be seeing a lot of improvements in the RL and in general post-training side, especially when it comes to continual learning. That's something I've been saying for a while. I think it's pretty mainstream opinion now. I think it wasn't before. But if you go look back one of my tweets, it was basically my prediction would be that continual learning would somewhat come pretty naturally. And I think that's happening with kind of self-distillation and context distillation and with RL in general, with much less sharp updates. And so I think this will start taking effect. And we will go from simple compaction of context, which is mediated by the model's intelligence on its own, to possibly test some training. And that's going to change a lot the way we interact with the models. That makes me so excited, because science is a problem that requires deep, long thinking. No great scientist was just winging it. All great scientists were always immersed in their thinking. And I think that when those things slot in, they superpower models' ability to do science. And because models that can remember a lot, that can adapt to kind of the field they're working on with few samples, possibly very cheaply, become monstrous researchers. Mm-hmm. And I think that, also we will see an acceleration of model capability because the models are so good. And that makes me very, very excited. And also, last thing also is that, maybe not too much on the frontier side, but I want to say this as well, is that I'm seeing, and I think our bet is going to be correct, that Europe is going to take its place. I think there's always been some disadvantage when it came to capital allocation to risk taking. I think that's going away very quickly. And I think we're going to see the results of that.
I mean, that's great to hear. We are pretty much excited about this. I mean, it's a very ambitious idea. I think we are into the pod. And one last question to you would be, we are living in an era where things are changing every week. I mean, like, we are really going an order of magnitude change every month with this recent capabilities, the recent kind of things happening, not just in model capability, but across domain now. So what do you think someone who is starting out college, who is in college, like who is just passing out school, who is 20-year-old, should focus on? Because there's so much noise and traditional, as you are coming from an academia, and you have seen how things are, as you said, like things are just too far. Like, you can't really connect the dots between what's really been going at frontier and what is going on in universities and traditional ecosystem. So what those guys should actually look forward to, and what is, you can say anything in terms of which can be really rewarding.
Yep. So first of all, if you want to be at the frontier, and if you feel like you're a person that can be at the frontier, and not everyone wants or can, I think, you shouldn't go to college, I think. Very bold statement, I know. I went to college for a lot of my life, a long time. You shouldn't. I think your new college, if you want to work on a frontier problem like machine learning, is find people like you. Make it so that your day is talking to them about that thing. And Twitter is a great way to do this. You guys, I'll never stress this enough. It changed my life. Because in Ensign chat or on the TL in Ensign part of X, you can find great people that discuss these things. And that's, I think, like, naturally going to guide you towards experimenting on your own and being very plastic and exploring and making a bunch of mistakes and publishing them. and that I think is going to be a much more significant piece of your education than university will, because university is mostly a social thing. Like if you want academic information, you can go and literally like Stanford lectures or MIT lectures for free on YouTube. Nobody's going to stop you. The main thing that for college is, it's a social thing. But I think it starts, social places that are better than college start emerging for these kind of things.
Awesome. That's great to hear. And I think, there are a lot of alphas coming out of this podcast. And basically, as you said, don't go to college. I think, it's a bold statement, but it's also true that we are pretty much going into that future where, university doesn't make sense at all, because what we are seeing today is not in any way correlatable to what is being taught in universities, right? So I think awesome. It was a great chat. It was a great pod. I hope you liked as well. And it was amazing conversation. Thank Francesco. For everyone listening, you can try Flywheel at flywheel.paradigma.ing. And basically, this is something, I think this is the frontier right now. If someone is trying to get into research, you can really explore what Frontier is working on. You can't really go to, you can, of course, learn code, how collab notebooks, import transforms, everything, but people should really understand what's being going at Frontier and how this research loop is getting transformed to how people like you are trying to transform this whole loop. And yeah, this is something amazingly Frontier, and people should absolutely try it out and read the blog as well at paradigma.ing/blog, and follow TensorQT on Twitter. Thanks for coming on. It was such a great conversation.
Thank you so much for having me. Thank you, everyone.
Likewise. See you in the next episode. Bye.
Bye.